doing problem 2a from section 5.2. Find the x values of all points where the function is defined as follows. Have any relative extrema, and then find the value of those relative extrema. That's pretty much what we've been doing for all of these problems. So step 1, find the critical numbers. That requires the derivative. So the derivative of this thing is negative 4 x squared minus 21 x minus 5. Okay, then we need to set this equal to 0. But let's just go ahead and we'll factor out a negative first, and then we'll set it equal to 0. Factoring out a negative usually makes it easier to factor, especially if that leading term is negative. So if you factor a negative out, all of these are going to become positive. Okay, and then again, this is a little bit of practice in factoring, but what you want to do is figure out two numbers that are going to multiply together to give you 4, and that's what's going to have to go first, and then the last numbers are going to have to be multiples of, or factors of 5. So it turns out there's two possible numbers for that are going to give us 4. It's either 4 and 1 or 2 and 2. In this particular case, 4 is the one that's going to work. Again, if you have trouble with the factoring, just you practice it, and if you really can't get it, just go check on the internet for some website that will do factoring for you. Or remember, there's also the quadratic formula. You can use any of those to figure out what the factors are going to be. Turns out this one factors like that. We're going to set that equal to 0. And then since we are setting it to 0, remember that negative is actually, we can just divide both sides by a negative. That's going to go away, at least in terms of how we find these critical numbers. So what we want to do next, take these two factors, 4x plus 1, set that equal to 0. X plus 5, set that equal to 0. This gives us x equals negative 1/4. And this gives us x equals negative 5. So we've got two critical numbers. The next step, we'll want to make our table of values to see what happens, whether this thing is increasing or decreasing, whether we have a minimum or max value. So we'll go from minus infinity up to the smaller of the two critical numbers, that's minus 5. We'll go from minus 5 up to the larger of the two, that's minus 1/4. And then from there to infinity. Okay. So remember, we want to pick test values. We want to find the sign of the derivative, sign of f prime. And finally, draw our conclusions from there. Okay, so a good test value here, let's pick negative 6. Let's pick negative 1, I think will work there. And then let's pick 0 for this last one. Okay, so we want to plug all these numbers into the derivative. So again, I think the factored form, fully factored form of the derivative is best to use, including that negative. So this is the derivative right here. We want to make sure and use that. So let's start with 0. 0 is usually the easiest one to see what happens. If I plug 0 here and here, both of those are going to be positive, and then we got a negative. So we'll have a negative number when we plug in 0. If I plug in negative 1 here, negative 4 plus 1, that's going to give me a negative number there. And a positive number here, so we've got a positive times a negative, that's going to be negative, but that negative there will then make it positive. Finally, negative 6, I believe if you plug that in, that will be negative, that will be negative, and then we've got a third negative, so makes it altogether negative. Okay, so that means that our function is decreasing, and then it's increasing, and then it's decreasing. So we've got a minimum value at negative 5, so min at negative 5. And then f of negative 5, that again, we have to plug that way back up here into the original function. That's not that much fun to do by hand, so I've got this stored in my calculator that we can find that pretty easily. So f of negative 5, you can of course use your calculator when you're wanting to do this as well. We get negative 377 over 6 for our actual minimum value. in fact, this is answering the second part of the question. It says, find the values of the relative extrema. Well, that's the value of the relative extrema. This is answering the first part of the question. Find the x value where the function has an extrema. So right there. Okay, then we've got a maximum value. Okay, and again, max, we know it's maximum because it was increasing, and then it was decreasing on the other side of the critical number. So that's at minus 1/4 for the x value. The y value, again, we plug that back into the original function. And I'm going to let my calculator do that. We get 827 over 96. Now remember, on your calculator, if you have a TI-84 or something like that, it will certainly give you a decimal value when you plug all that into your calculator, when you plug -1/4 or 5 in there. You can change that decimal value. If you just go to press that math button on your calculator, you should see a thing that says frac on it. So just go to the frac, press enter, and then it'll change the decimal that you had into a fraction. That's the way that you'll need to enter those answers on MyMathLab, unless MyMathLab tells you that you need to round it. Okay.